This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to Indoor Air Quality Radio. We've got a great show for you today. It's show number 489, January 5th, 2018. Have to get used to that. And we've got Mr. Bruce White, Vice President of American Environmental Specialists out in Huntington Beach, California. He's also the Indoor Air Quality Association's first Vice President. We're going to talk a little bit about wildfires and indoor air quality, hospital construction monitoring, the new OSHA Silica Rule, and more. But before we do, let's thank our marquee sponsors.
IAQ Radio marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Particles Plus, engineers and manufacturers, feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Please be sure to thank our sponsors for their support of IAQ Radio. All right, and let's turn it over to the Z-Man for today's IAQ Radio trivia question.
And now you can win a cool prize. It's time for the IAQ Radio trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com, or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio trivia question.
Hello, everyone, and welcome to the first trivia question of 2018. The IQ Radio trivia question for today, Friday, January 5, 2018, has been sponsored by Ideas, the solution chemistry company creating unique solutions to odor removal, surface cleaning, and decontamination problems. Here is today's trivia question. What is the official rule governing the naming of a wildfire in the United States? Back to you, Joe.
Thank you, Cliff. Okay, so we've got Bruce White on the line today. We're looking forward to a kind of wide-ranging discussion. Bruce brings kind of a unique perspective to his consulting. He's been in the environmental business for over 30 years, and he's got a really wide range of experience out there in the real world. He started way back in the 70s in the restoration industry, or I guess maybe the 80s. I'll have to check with him on that, with Blackman Mooring, and he did remediation work. They went into the asbestos abatement world. From there, he also jumped over into the consulting world probably about 20 years ago now, and also sold safety supplies and equipment for a while. So he's got a diverse background. Also been a long-time volunteer for industry-related associations, and he's currently the first vice president of the Indoor Air Quality Association. Bruce, do we have you on the line?
Yes. Good morning, Joe. Good morning, Cliff, and good morning all the attendees out there from the land of fruits and nuts, where it's 72 degrees today.
The land of
flakes.
I'll tell you what, Bruce, it's hard to hear that 72 degrees when it's minus 10 out here somewhere up on the mountain. But anyway, what you've been around a long time. You went from the contracting, you did the sales or the health and safety equipment and supplies business, and been in the consulting world for quite a while now. How does that background, I guess, influence your consulting services or your approach to consulting services?
Well, I think it gives me a really unique perspective on both the restoration and the remediation, or the environmental side of our businesses. Having done what I call the environmental circle of life, been the contractor, done the physical removal, know what equipment worked and didn't work, selling the equipment that works and doesn't work, and working with consultants, and now being a consultant sort of gives me a unique perspective on what each of those entities goes through to accomplish a job. And I think everybody would probably agree that has any long-term working background that especially on the environmental side, there was always sort of this antagonistic relationship between the consultant and the contractor. And what ended up happening in many cases is it basically did a disservice to the client that we were both working for. And I think my perspective is I see what contractors go through. I know what consultants are subjected to. I know what equipment works. So I think I have a very good perspective on how a project can come together without that sort of antagonistic working relationship.
I wonder if you ever, I kind of have a similar background, but I did more consulting early on, and now I do a little more construction with another company. But do you ever end up talking your clients out of using you and just basically say, look, you really don't need a consultant on this project. You've got a good contractor in there. They know what they're doing. Does that happen?
We do, and it's quite frequent. And the reason that we do that is if we know, we have a pretty good handle on who does good work out here and who does not do good work, and when they need supervision and when they don't need supervision. And the end goal typically of our clients is we want to serve them in the best way. And if it means we need to be on site day to day, we'll certainly advise them of that. If not, then we probably will end up only doing some sort of a visual and or laboratory sampling to verify that the work's been done. I think they always want that at the end, typically, Joe. But it's not necessary that we be on site day to day to monitor, because most of the contractors, especially in the environmental world, know that they're at great risk, not only from exposure to their employees, but from regulatory exposure. So they're usually pretty keen to follow the rules and do things the right way.
You're in Southern Cal, and there hasn't been as many fires in Southern Cal, but I want you to talk to listeners a little bit about the type of consulting work you do on fire-related projects.
So primarily on fire-related projects, we are only involved in the commercial aspects of it. We don't do any residential, except if we're doing wildfire smoke and soot sampling. And wildfires are completely different than a home fire in that the deposition of the material is usually quite different than you would have in a structure that's burned. Wildfires are typically a mix of like gases and vapors and really fine particles like soot, when wood and other organic material is burned. But when you have a structure that burns, you end up with a whole slew of different types of toxins that can be out there, from hydrogen cyanide to PCBs to asbestos to lead that's fumed to dioxins and whatever else that may have been consumed in that fire. So in those particular cases, we'll normally get involved to do some air sampling and particulate sampling to determine what is in the resulting soot. And to that degree, there's basically three different things that we look at when we're looking at either wildfires or commercial fires, and that's char, which is burned material that we can identify by the morphology or the color or what it looks like. We also look at what is called ash, which is the leftover residue when you've had complete combustion. And then we'll look at soot particles, which is the black carbonaceous material that is usually a result of incomplete combustion. And then based upon those findings, we'll advise our client as to what the cleanup methods and write a scope of work if necessary. I really think most restoration contractors have a good handle on what needs to be cleaned up. So writing the scope of work is not necessarily always done. I would say it's probably done in 10% of the cases where it might be a very complex situation. But other than that, we leave it up to the restoration contractors to make the call on what needs to be done.
Now, before the show, we talked a little bit about the insurance industry out there, and I guess you see some claims, and I don't want to put any words in your mouth, but there may be claims out there that are, I don't know, a little maybe exaggerated, might be the word, where people want, maybe they've been in the area where there was a wildfire, there's been some soot or some staining on the exterior, and they want the whole home repainted. What are you seeing with respect to that? Is it a common problem, or is it something that you just see once in a great while?
No, when we see these large wildfires like we've seen recently, we see a lot of solicitation of homeowners and business owners in the remaining buildings that may be miles from the actual wildfire and may not have any soot deposition, but the smoke traveled in that direction. So they may have an odor, but they may have no actual particulate deposition. Yet they're solicited by a variety of different people to help them provide a claim, and then that claim goes to the insurance carrier, and they have to defend that. And that's typically when consultants will get involved, and they will go out there and do this smoke and soot testing to verify or deny that problem exists. There was a really good study done by a couple of people, I think it was 3 or 4 years ago, that looked at how the soot fell out from wildfires, and typically it falls out within a couple miles of the actual burn site. The rest is simply odors, which is the gas or the vapor part that I had mentioned before. So when we see these claims, we find entire neighborhoods that are being solicited by adjusters or attorneys or a variety of other folks that they're trying to have them provide a claim so that they can take their portion of the claim.
And how do what type of sampling are you doing? Are you doing like a dust wipe? What technique are you using? Are you following any kind of standard? I know there's not a lot to go by out there. I know the labs have their own way of doing things. How do you prefer?
So we typically prefer a micro vacuum sample or a tape lift. We're not big fans of the alcohol wipe, which a lot of people do. We think that it's a better sample if we can get a micro vacuum. So we use a 25 millimeter or a 0.45 micron, mixed cellulose ester cassette, and we'll vacuum a certain area and then send that into the lab. Same thing with the tape lift. And I think that gives us a much better idea of what is going on. Very seldom is it going to be air sampling. We can do air sampling, but typically it's all gravitated out, so it's sitting on either horizontal or vertical surfaces. So we tend to lean towards the surface sampling.
And Cliff, do you want to jump in here? I know this is your area.
Yeah, I guess I've got a couple of questions. Bruce, one of the things, I guess from your experience with BMS and restoration, that will be different, I think, is really how the odor gets into these houses or gets into these buildings. In a wildfire, the odor's on the outside and it's coming in. When the fire is within the structure, it's on the inside and it's trying to get out. So, if you could comment on, what techniques seem to work well for odor removal and cleaning, I think that our listeners would appreciate it.
Sure. Well, I'll go back to the example of the wildfire. So you may not have any actual particulate deposition, but you may have an odor that's become entrained in the house, and it typically is going to enter through the attic vents or when the doors are opened and closed, and the entire area is just enveloped in that odor. So naturally it's going to work its way into the house. As long as there is no fine particulate deposition, I think there's a variety of different ways that people can go about deodorizing their houses. You can use foggers, you can use an ozone machine, providing that the home is not occupied at the time of the ozone. There's all sorts of odor gel blocks that can be done. You can put in carbon filters into the system and recirculate the air. So I think it's all the tools that the restoration guys have out there right now that works very, very well. I don't think there's any one that's better than the other. In some cases, when the odor has been really heavy, we've seen this in several instances when they're within probably a couple miles of the home, of the actual fire site, as they end up having to clean the carpets. Anything that's porous has to get cleaned, and that usually takes care of the problem. But I think.
What about the outside? What about the outside of the house? Washing the outside of the house.
Oh, sure.
It would seem to me that, if you had odor get in through the vents and you had odor get in through doors and so on and so forth, that you would probably have fine particulate deposition, or else you're going to have odor adsorbed or absorbed onto the exterior of the structure. So would you ever recommend that, or people generally do that or not?
I think the people, at least out here in California, people have the general knowledge that you're going to have some very fine layer of particulate deposition on the exterior. So they will do everything from rinsing the roof off to rinsing the stucco off, sidewalks. They water the grass simply to entrain it down into the soil so that takes care of that part, and then they wash off concrete and cars and everything else. So, yeah.
All right, I want to turn over to another topic I noticed you spoke on. I don't know where, but it was hospital construction monitoring. And, you've got the ICRA and the PCRAs. And first of all, the ICRA is what, an infection control risk assessment. Tell people what that is and how you go about developing one of those.
Sure. So anytime work is done in a hospital, they have to have a permit to do the work. If they're going to lift a ceiling tile in a hallway, they have to apply for what's called an infection control risk assessment permit. And this permitting process is basically broken down into several stages, and just generally, depending on the type of work they're doing, it'll be a type A through a type D. So a type A, as an example, would be lifting a ceiling tile to do an inspection and then putting the ceiling tile back. An example of the type D would be a major demolition or a major renovation of a section of a hospital, and then you have everything in between that. The purpose of it is hospitals exist with one primary goal in mind, and that goal in mind is to do no harm to the patient or the population. They're there to make them well. Whenever we're doing demolition and renovations or any kind of activities in the hospital, we have the ability to create small to copious amounts of dust and particulate. And we know from a lot of scientific studies on that dust, there are microbes and there's bacteria that are all over the hospital. So the goal of the infection control risk assessment is to sort of outline where you're going to be working, what kind of work you're going to be doing, and then assigning a patient risk group to that level. And they basically run from class 1 to class 4. Class 1 being minimal risk. Maybe it's the office or admin area of a hospital where you're going to be doing work, and it's going to be minimal work, so you would assign that a lower risk factor than you would if you were going to be working, let's say, in an operating room or a cath lab or a neonatal intensive care unit where you're installing something. So these permits are put in place to protect those patients and protect those workers, or I should say that population that will be affected by it. And they look at a variety of things. They don't look just at dust. They look at interim life safety control. So are you going to be blocking a stairwell? Are you going to be blocking an egress point? Are you going to be causing building vibration? Are you going to be causing noise, intense light, all these different things? And the permit is to protect everybody within that general area, but above and below those areas, because we know whenever we're doing normal construction activities, we can create vibration. And that vibration can go above and can go below, especially if they're working on any kind of structural framing. And when we have that vibration, we actually have data that shows that vibration will cause a sifting effect of fine particulate in the areas below the work area. So we basically monitor all those different areas during the course of construction. The contractor, in turn, since they are applying for this permit, and the permit usually involves the infection control department, the risk management group, engineering and facilities, a bunch of different parties. So you have a lot of people that are involved in this permitting process to make sure that we look at all different aspects of what could go wrong and has gone wrong in previous construction. So once everybody's looked at this, then they assign the permit, and then the contractor begins the work. And he usually has a variety of precautions that he puts in place. The minimum would be a critical barrier. They normally install air filtration devices to create a negative pressure environment. They'll usually have tack mats. They may use PPE, so they have the suits that they would take off before they exit the work area. And all of these help provide a level of protection to the patient population and the occupants of the building. So that is what an ICRA is. PICRA is basically the very same thing, and it's designed for new construction in hospitals. So PICRA stands for Pre-Construction Risk Assessment, and it's basically the same thing. If you are going to be building a new hospital, you want to make sure that and they're typically built near or adjacent to existing healthcare facilities, that whatever work you're going to be doing will not affect the existing healthcare facility. And so that is what a pre-construction risk assessment is about. And it goes through the same processes of looking at, are you going to cause building vibration to the existing facility if you're driving piles for new structural supports, or a parking garage, or are you going to create lots of dust when you have traffic in the area? And they look at all these different aspects to make sure it has no impact on the existing healthcare facility.
Bruce, you mentioned doing monitoring of these work areas. Can you go into a little more detail for listeners about the type of monitoring? And I would imagine it's different levels of monitoring, but can you give us a little more detail on how you perform that monitoring?
Sure. So usually when we're doing the monitoring, there's two aspects of it. One is the visual monitoring, and then one is typically particulate monitoring, because we know from a lot of studies that either fungal spores or microbes can travel with the dust, and wherever the dust goes, then you have that issue. So the visual monitoring is usually making sure that the contractor has set up his precautionary devices and that they're in working order. So we would check a negative air by using the magnehelic gauge, where we can visualize it from outside the work area, therefore not having to enter the work area. We'll look at their tack mat setups. We'll look at their critical barriers, and then we'll monitor the employees occasionally to see how they're removing debris or bringing materials in to make sure that carts are covered. So if they are removing, let's say, drywall in a cath lab, we want to make sure that when that material comes out through the critical barrier, that it's completely sealed in a cart. So the cart has a cover on it, the wheels have been wiped off. That would be the visual aspect. We're also a very large fan of doing particulate monitoring. And there's so many new devices for particulate monitoring. Particles Plus, one of your sponsors, has great particle monitors that we established during the transportation corridor section of the work. So we follow the workers and the materials as they enter and exit that space. There's another device called AirThinks, which is it looks like a thermostat that you can mount on a wall. It's very non-intrusive. The cost of air quality monitoring devices has become really, really low, so it makes it very affordable to use these devices. And speaking of that, almost all these devices now can do remote monitoring and reporting, which is a very nice adjunct, so that the consultant or the person that's doing the monitoring doesn't have to sit there and download data. They can simply get it by the cloud. And most of the devices that we use, I can pick up my iPhone, my iTablet, my desktop, my laptop, and I can log into an account, and I can see exactly what's going on from moment to moment, and it's all real time. So a lot of these devices report a variety of different things: air pressure, temperature, relative humidity, particle sizes, usually PM10, PM5, PM1. They'll report VOCs, they'll report formaldehyde, they'll report carbon dioxide, and it's a very helpful tool for the consultant that is doing hospital monitoring, because you don't have to stand there to do it. Another advantage that we see on a lot of these too is that you can invite other people to be a user and receive that same information. So normally when we are doing monitoring, we want the facilities management and we want the risk management to know if we have an event. And an event would be some sort of a level that you set that if it's exceeded, would notify you by text or email that that event has occurred, so that we can quickly figure out what is going on. And that's the beauty about these new monitoring devices is that they do report in real time, and you can have specific people on different levels to receive the information. So it makes it a lot more economical for the hospital to do the monitoring now than it did. So it's a great tool to have.
You mentioned a product, Air Sync, I think you said. Can you describe that one for me a little bit? I'm not familiar with it.
Sure, yeah. It's AirThinx, AirThinx. And it's a small monitoring device that reports, I think it's 9 parameters. It reports 3 particle sizes, relative humidity, temperature, carbon dioxide, formaldehyde, and total VOCs. And it's a device that looks about the size of a thermostat that you would attach to the wall. It runs on battery or it runs on power, either one. It's very similar to the Particle Plus device. And as with the Particle Plus device, reports a variety of different parameters, and that is very useful for any consultant, whether they be doing healthcare monitoring or any other type of monitoring. And once again, these devices normally will connect either Bluetooth or wireless or 3G or internet, whatever communications devices are available in these locations. And they're very inexpensive now. So we've seen some. There's a device called Aware, AWAIR, that I think runs $300, and it reports 4 or 5 parameters. So you can get them from, $200 all the way up to $10,000. It just depends on the accuracy that you want. Obviously, the more expensive, probably the more accurate would be my assumption. But they're very valuable devices for the consultant that is trying to follow a project that may last from 2 weeks to several months.
Bruce, you mentioned following, maybe I misunderstood, following the people, the construction workers who were removing debris. You have someone with a particle counter like following them? Maybe I misunderstood.
No, we will install these devices, stationary devices, along the path of travel. So.
Okay.
As an example, if somebody is working in the second floor and we know they're going to go down a certain hallway to a certain elevator and then exit the building, we would install these devices, usually 2 or 3 of them on the pathway so that we can follow them.
And
and that's the beauty about them, is that they're remote, so we can see what's going on from moment to moment during their travel.
The goal being that you want those particle levels to stay at or below background, or close to background.
Correct.
Do you have a specific goal in mind within 10%? Do you look at a range of particles or one specific particle size?
No, we look at any of the respirable particles, so PM10 and smaller.
Okay.
So typically we look at PM10, PM either 2.5 or 5, and PM1.
Let me get one more quick one in before we have to go to halftime here. You've got you mentioned. Let me do this for contractors out there and consultants. What are a couple of things that are commonly overlooked? You mentioned vibration several times. I assume that's something that most people would know. You've got to be careful about when doing work in a hospital. What are some other common issues that come up that maybe people don't think about?
Well, I think that the dust tracking issue is of paramount importance. So there was a study done by SmithGlaxoKline about how much particulate is removed from footwear of construction workers when they exit a work area, and a series of tack mats were put down there. Typically, the tack mats that you see in the hospital construction work is simply a 2 by 3 foot mat that sticks out from either the critical barrier point or from the decon. And on a tack mat that size, a person is going to take 2 steps. Well, when you look at this study, it showed that it takes 6 to 8 steps to remove 80% of the particulate. So what happens is you're removing probably 20 to 30% of the particulate from the footwear or the bottom of the shoe or whatever they have on, and the other 70% travels with them down the hallways or down the corridor or into the elevator. And that's where it becomes problematic. And there are other types of matting material that are out there that will capture more of that in a smaller space. And not to go into great detail, but they're fairly expensive, but they're reusable. And in the long run, it's cheaper than a tack mat.
Mm-hmm. Okay.
I can send you that information, and you can pass it along to any of your listeners that would like to have that.
Sure. And I would imagine you could always just put several tack mats in a row as well. I think it's a very important point you made, though, that just one tack mat may not do the job, may not get you what you want as far as reduction.
Correct.
All right. Bruce, fantastic. Great stuff. We're going to break here for halftime. When we come back for the second half with Bruce White, we're going to talk a little bit about the new OSHA Silica Rule. We're also going to talk a little bit about the upcoming Indoor Air Quality Association ASHRAE Conference in Chicago. That'll be 22 to 24, January 22 to 24. Hope to see a lot of listeners at that event. But let's first thank our sponsors.
IAQ Radio would like to thank our association sponsors. The Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at iaqa.org. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them, wolfsense.com. IAQ marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's jondon.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at iaq.net. Particles Plus, engineers and manufacturers, feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
We're back for the second half of our interview. We've got Bruce White out of Huntington Beach, California. Bruce, I want to talk a little bit about the new OSHA Silica Rule. I see a lot of interest in that. I want to talk to listeners a little bit about, first of all, who's affected by that. You know, we deal with a lot of restoration people, general contractors, construction, asbestos abatement, lead abatement. Who do you see within our listener group that would be affected by that new rule?
The simple answer is everyone. And it can be everyone that does the work, and it can be the occupants where the work is being done. And we see both sides of that happening as we speak. So the new OSHA crystalline silica standard was supposed to go into effect earlier last year, and it didn't. It went into effect, I think, in October was the final decision. And it affects anybody that is disturbing or creating or sawing or cutting or remodeling anything that has silica in it. And as we all know, silica is the basic building block of all construction, whether it be the concrete, whether it be the stucco, whether it be the marble countertops, whether it be the porcelain tile, you name it in that structure, a lot of it has crystalline silica in it. So this rule affects probably 400,000 to 600,000 people in the general industry and the construction industry, not including the shipbuilding industry. I think what's really interesting about this rule is a couple things, and your listeners may or may not be aware. The construction industry had an exposure, permissible exposure limit of 250 micrograms per cubic meter of air. That's been reduced to 50, so an 80% reduction. There were several studies done in the last 4 years that showed we could barely reach the 250 microgram level, much less the 50 microgram level.
During what kind of activity?
For any kind of construction material, any kind of activity that would disturb the material. So it could be saw cutting, grinding, drilling, tooling, pouring, demolition, breaking, you name it. So all of these different types of activities were affected.
Okay.
So it's going to be really interesting to see how the construction industry primarily, but the restoration and remediation industry react to this thing. Most of the people in the remediation industry normally are wearing PPE anyways. What's interesting about this rule is they have this thing in the back of the law called Table 1. And Table 1 basically outlines if you're doing this type of activity with this type of tool, this is the respiratory requirements that you have. A lot of them, you don't have to do anything as long as these tools have some sort of a water feed on them. So if you have let's say a concrete cutting device, as long as it has a water feed, you're not required to wear a respirator if you're cutting for less than 4 hours. If you're cutting for more than 4 hours, you have to wear a respirator that has an assigned protection factor of 10, so that would be a half-face respirator. But this table is very, very interesting in the way that they did it. The other interesting part about this rule is it requires that if you're going to be disturbing a material that contains silica, that you have to have a written exposure control plan. Now, that's a very daunting task to most people that are doing this day to day. There's a couple of really good websites that people can go to. California has a great one where you input the information on your project, you tell them what kind of work you're going to do, and it tells you right off the bat how to do the protection. And it gives it to you real time, and probably 10 minutes you could fill one out. So that's another requirement of that. I think one of the other things is that this new rule has an action level of 25 micrograms of silica per cubic meter. Most of the contractors right now, I think, are struggling with their exposure assessments. People do not know or are not aware of what their exposure levels are to their employees in the different classes of work that they perform. And therein lies one of the big issues is we find that there is a lack of consultants that can go out and do sampling. The sampling as it stands right now is getting very expensive. So that is sort of an issue. The laboratory fees are rather steep. So a lot of contractors are staying away from that. One other interesting aspect that we have been following is the UC Berkeley, which is the University of California at Berkeley, has a construction technology and ergonomics school, and we're finding that a lot of these equipment manufacturers are seeking out their advice on how to tailor these tools to the environments that they're working in. So we're seeing a lot of changes in how the tooling is being done, and I think we'll see over the next 5 years some excellent tooling coming out that contractors should consider changing out because that's going to be a big aspect of how you protect your workers from the exposures.
Bruce, I have to say I have not looked at that standard at all, and I want to just kind of back up a minute. First of all, on the monitoring, can you presume what your exposure is going to be based on other people's monitoring?
No.
Okay.
You have to monitor your own people.
Okay.
And it makes sense. It's just like any other. Let's compare it to asbestos, since this is a very similar thing. If your employees are removing, acoustic ceiling material, they may be doing it in a different method than contractor B and his people. So their exposures may be different than your exposures, even though you're removing the same materials. So each contractor is responsible to do their own exposure monitoring.
And this exposure monitoring, I haven't read it, so I'm assuming it's a personal sampling pump with a cassette in the breathing zone. Is it similar to asbestos?
Yep. And yes, it's very similar to asbestos. It uses what's called a cyclone sampler.
Okay.
There's a new tool that's come out that I just saw at the last AIHA show in Seattle, and I believe it's called NanoZen, NanoZen, and it's a small personal sampler that reports the information without having to go through a laboratory. The device at the point seemed to be fairly expensive. The price point was pretty high, as I recall. But your listeners, if they're interested in that, should probably go onto the web and look for that.
Now, you mentioned the sampling. Okay, we're using a cyclone collector, and then it's going to a laboratory, and I assume the laboratory's pricing is based on the demand at this point. And I'm wondering what kind of ballpark idea can you give people for the type of the amount to have a sample analyzed?
Without naming labs, the last fee that we received for a 72-hour turnaround for crystalline silica sampling was $280 per sample.
Wow!
So it's fairly high. A phase contrast microscopy sample, depending on where you're located, you can probably get from anywhere from $7 to $20. So it's pretty pricey.
I'll say.
Pretty pricey. I'm hoping it's going to go down.
How many now? What do you, as far as the sampling goes, for the contractors out there? I mean, a lot of our people cut into concrete. They do a lot of the activities you described earlier. So if I'm doing this sampling, how many people do I have to sample on my crew?
Well, you should sample 20% of the people doing the same type of task.
Okay.
So most of our people out there that are doing restoration remediation might have a crew of 5 people, and 3 may be doing the same task, if you would. So they would have to sample 1 person. But you have to sample them by task. So if somebody is drilling, that is different than somebody saw cutting. And if somebody's doing demolition of the concrete, that's separate from the saw cutting and the drilling. So it's driven by the task, not by the amount of people necessarily. Although you should, out of an abundance of precaution, OSHA usually likes to see 20% of that task be sampled.
Okay. And so when you're doing this sampling, how many samples? I mean, is it going to take more than 1 sample per person to get an 8-hour? I would assume they're looking for an 8-hour time-weighted average, but I could be wrong.
Sure. No, they would like an 8-hour. Some of these tasks only last 3 or 4 hours. So you basically have to do the math and extrapolate that if they were doing this continuously for 8 hours, then that 3-hour exposure would be translated into the 8-hour exposure. So it's usually just 1 sample per person per task is typically how it breaks down. Because normally remediation contractors, which are completely different than a construction contractor, you may have 20 people doing the same task. Thereby, you would probably sample 4 of them. But typically, remediation are smaller crews than a construction site crew.
Okay. I'm getting a couple texts in here. One is that PI OSHA, I'm not sure what that is, expects most construction employers to implement the specified exposure control measures in Table 1. Therefore, they will not be required to, I'm not sure what that means, sample. There are new sampling devices that do particle size separation superior to cyclone. Someone saw that at the EMSL booth, which I think you mentioned there's some new technologies coming out.
Right.
Right. And then one is that individuals need to consult Table 1 in the OSHA standard for alternatives to sampling. What are alternatives to sampling? Are you familiar with those, Bruce?
Yeah. So they have what they call alternative exposure control methods. And so if a contractor or an employer doesn't implement the control methods on Table 1, then they have to determine the amount of silica that workers are exposed to or may reasonably be exposed to if they are at or above the action level of 25 micrograms. That's the requirement of the alternative exposure method. They also have to use some dust controls. They have to protect the workers from silica above the PEL, which we already talked about. And then they have to provide respirators so the workers, when the dust controls and these safe work methods, can't limit the exposure. So what that basically means is if you don't want to follow Table 1, then you have to do these alternative exposure control methods, and that's where you determine if they are at or above the action level, which means, once again, you're doing site monitoring to make sure they are below that 25 micrograms, or if they are above that, then you have to see if they're above the 50 micrograms. So you're back to an exposure sampling.
And if they're above 50,
and really,
then
what we want to do is we want to stay away from sampling as much as we can, and implement other types of processes to reduce that exposure. But at some point, the employer is definitely going to have to do some exposure monitoring if they don't implement Table 1.
And they can always just go in and implement, but that then requires PPE, you've got to have a respiratory protection program, you've got to have fit testing, medical evaluation, all of those things. Is there medical surveillance or just evaluation?
There is medical surveillance if they're wearing a respirator. That's an OSHA requirement that if you wear a respirator, then you have to have a medical program in place. But typically, it's I believe, I don't have the rule in front of me, so I may be speaking, but I think you do have to offer a medical exam that includes a chest X-ray and lung function test.
Okay.
There's the training requirement, and then there's, of course, the record-keeping requirement.
Sure. But I don't see how they're going to avoid having to issue respirators when they're doing things like cutting concrete. I mean, it's going to be really tough to keep your exposure below the PEL, let alone the action level. But maybe I'm wrong. I'm making this assumption based on what I see in the field. Do you see people able to keep it below? I mean, this is, I know, very new. I don't know how much of this monitoring you've done. Do you see people cutting concrete being able to keep below the PEL?
Yes, we do. And it's typically with tools, the new generation of tools that are water and or vacuum assist devices.
Yep.
So at the point of cutting, it has the water spray so that it just remains encapsulated into the water itself.
So you're going to spend some money on those too.
You know, once you cut that concrete, and now you have this concrete dust that is going to be generated once the water dries, how are you cleaning that up? And we see people. We recently had a project where they were very diligent about using these water cutting saws. They were cutting concrete curbs every 3 feet to demolish them. But then we had all this concrete sludge that turned to concrete dust, and they were simply sweeping and shoveling it up. Well, that sort of defeats the whole purpose there. So it's sort of the follow-through that has to be done.
This is going to be a big issue. I don't know. I mean, in the restoration world, I don't know that we get into that much, as much as the construction world where they're actually cutting into slabs or they're, doing things like you described, cutting curbs or cutting into, you mentioned stucco. How much, is there a lot of silica in stucco?
Oh, yeah.
Okay.
Yeah, there is.
Okay.
And back to the restoration, I don't want to say that restoration is exempt, because quite honestly, there are some pretty good exposures that can be presented to people doing restoration. So, let's take a house that's had a fire.
All right.
You're going to be demoing countertops. You're going to be demoing porcelain tile. You're going to be demoing sinks or bathtubs or things of that nature. Demoing stucco. All of those activities have the ability to have some crystalline silica in them. Because granite is stone, stone is silica. It's a simple translation. There's not much, with the exception of wood and asphalt shingles in a house, and the metal parts that may not have silica in them. So there's a lot of chances for exposure to those employees.
Sounds like we're going to need to do another show on this topic. But Cliff, before I go to the next topic, any follow-ups from you?
No, it's just complicated.
It is. It's a lot of. It's a big change. I mean, that rule was a big deal, and I think it kind of went a little under the radar, at least in our industry. In the construction world, I know they've been all over this for some time. But anyway, Bruce, let's change topics just a bit. I want to go back to a text question that I thought was a good one when we were talking about monitoring the hospital construction. One of our listeners asked, how do you field calibrate your dust tracks, smoke tubes, particle generators, etc.? Can you talk a little bit about the field calibration of your equipment and how important that is?
So, depending on the device manufacturer, that's the calibration standard that you would have, whether it be a Gray Wolf or a dust track. Depending on whoever the manufacturer of the device is, basically provides you with the information on how that should be field calibrated. And so that would be the direction that we do. And that's primarily just for particulate counters. And we don't really use smoke tubes per se, other than if we have a question about airflow. If we think that their manometer is reading wrong, we'll smoke tube test the openings to make sure that we have a negative airflow. But primarily, we follow the manufacturer's calibration requirements.
Okay. And then I got another interesting, this is an interesting comment. Drywall sanding, can that generate an appreciable amount of silica? I've got a listener that thinks it does, and I'm curious what your thoughts are on that.
Well, I would have the listener look at the MSDS sheet on whatever the materials is that they have questions on.
Okay.
One of the big ones we get is drywall joint compound or texturing material. If you look on
I think that's what he meant.
Caution panel, it very clearly says, especially on the SDS, that it is a respiration hazard, and it says it contains crystalline silica in it. So it's pretty right in the face, I think.
Well, then that would be a huge issue for the restoration world. When they're cutting out drywall joint compound, etc. If it's and you don't know. I mean, you're going into a 90, or a 30-year-old home, cutting out all that drywall and joint compound. You can't go to the MSDS. You don't know what they used.
Right. So you have to make the assumption that it does. I mean, we know for a fact that the joint compounds that are being manufactured today are very, very similar to the ones that were manufactured 20, 30 years ago. So I think the employer has to make the assumption that if they're going to be cutting, demoing, doing whatever, that there has to be some level of protection of the employee or methods used that controls the dust. As long as you can control the dust, then you don't have that problem. And there's been some really interesting tooling that's going on recently, especially for the concrete world, on drilling and cutting tools. And basically what they're doing is they're removing the worker from the exact point of cut, and they're standing back. There's a really cool tool that if anybody wants to go look at online, it's called the Ergomech Drill Boss. And it's basically a hammer drill that's mounted to a device that puts the employee about 10 feet away from the point of drilling, even though he's controlling the drilling. And what that does is get you out of the dust breathing zone to where there's no exposure.
Interesting topic, Bruce. Very interesting. And then fiberglass. What about fiberglass dust? I mean, there's silica in fiberglass. Maybe I'm...
No, I mean, fiberglass is basically a glass product, and it could have some small amounts of silica in it.
Okay.
But at this point, I don't think that OSHA is... There's a couple of small requirements that they have for fiberglass exposure, but it's more dermal than it is inhalation. I believe they do have one on inhalation. I'd have to look that up, to be honest with you, Joe. But
sure.
I don't see it as of yet being an issue.
We're gonna do another show on this topic, get into a little more detail. But let's get back to another subject before we go, Bruce. I want you to tell listeners a little bit about what's coming up with the IAQA, the Indoor Air Quality Association conference coming up here. What is it, the 22nd through the 24th of January up in Chicago? Yeah,
so since we are, the Indoor Air Quality Association is in conjunction with the AHR, which is the ASHRAE Expo and exhibit. We're going to be having it in balmy Chicago in
Lovely
January.
Time of year.
And the topics this year, I think, are really very dynamic. We have everything from remote environmental monitoring of sensors to some of the normal topics that we see. But we think it's going to be just a great expo, lots of great speakers, very good keynote speaker as well, lots of committees, and we would love to have all your listeners attend or get involved with Indoor Air Quality Association. We have made some big changes here in the last 3 months. I'm not sure if your listeners are aware or not, but that we have teamed up with a distributor and with a training company so that they can now get health and safety, first aid, CPR, confined space, asbestos, lead, mold courses, all through the IAQA at a discount, which means that if you're a member and you get a 20% discount, you basically paid for your membership on one training course.
Okay, and what about, I believe, I know Carl Grimes was speaking at the conference, and wasn't he speaking with a couple of other people? They had some kind of I don't know if you'd remember or not, some kind of a panel discussion, I think it was. Do you know that one off the top of your head?
I don't have it off the top of my head.
Okay.
But, I was just going to look and see what the conference was, but for some reason my computer
No
is
problem,
down.
Bruce. Well, I'm sure people can go to the IAQA.org website and take a look at the agenda there. I saw some very good presentations, a little different take on things this year than I've seen in the past. I know there were a couple panels that were going to talk about some current issues, and I know the healthy homes was one of the issues they were looking at, and that's been a big topic lately. So I encourage people to take a look, and if you're out there, say hello. I'll be there attending and reporting on the conference. We'll do a show after I get back, probably on the 20, what would that be, the 27th, I guess that would be. We'll probably do a little show and wrap things up from the IAQA ASHRAE conference and the AHR. That AHR is mind-boggling if you've never been there. It's just thousands of exhibitors that have everything from widgets to air movers. So just a very interesting, and I bet there's a lot of the people that provide the type of equipment we've been talking about here that will be at that show as well.
Yep, I think you're right.
All right, Bruce. Any final thoughts before we go? Anything you'd like to add?
Well, the only thing that I would like to sort of plant an idea in everybody's minds is it seems like both from the commercial world, the professional world, the healthcare world, that indoor air quality is basically rapidly becoming a big concern, especially things like carbon dioxide, carbon monoxide, smog, and how it affects people in their working environments. I mean, we spend probably 80% of our time in a built environment world, which means we have lots of opportunities to have things affect us. So I would just urge them to kind of keep an eye on the indoor air quality world in general and see what's going on. There's lots of great studies that have been done and are being conducted right now. The Well Building Institute is one of the great ones. Harvard School for Health just recently published a study about the effects of carbon dioxide on schools and colleges and how it affects their learning capability. So lots of good information coming out, and just kind of keep an eye on it.
Bruce, I had another couple questions I wanted to get to. So it looks like I may have time for one more. I wanted to ask you a little bit about any unusual or different kind of indoor air quality issues or topics that you see kind of up and coming. I know you just mentioned that it's an up and coming top issue. Is there anything in particular that you've seen, any kind of unusual requests you've gotten lately?
Well, I think that the topic of gases and vapors is quickly coming to the forefront more than particulate. I think the VOCs and the formaldehydes and the other gases and carbon dioxide and carbon monoxide, we're finding from these studies from like the Harvard School of Health dramatically affect somebody's cognitive abilities in a variety of different ways. So I just think that we are going to be focusing more on the indoor environment, more so here in the future than we have in the past. And I think we're going to find out some astounding information as all these studies continue.
One more comment from the answer man here. I think this is a good addition to the discussion we had on the drywall. Drywall sampling for asbestos. You've got to do asbestos sampling anyway in many cases, and what he's saying that the PLM sample will not detect percent of silica, but that you could take that bulk sample and maybe have it analyzed by XRD, X-ray diffraction, to give you some idea if there's silica in that particular sample. So I think it's a good tip for listeners.
Yep. Good point.
All
Very
right.
good point.
Well, Bruce, Cliff, before we go, any final thoughts, questions from you?
I'm good, Joe. Thanks.
All right. Well, Bruce White, thanks so much for taking an hour or so out of your time here. I know you're a busy guy out there with consulting work and then all your volunteer work, and thank you for that. And I look forward to seeing you in a couple of weeks in Chicago.
Absolutely, and thanks for having us on.
Our pleasure. This is Radio Joe Hughes saying thanks to this week's guest, Mr. Bruce White. out of the Huntington Beach, California area. Beautiful weather they're having out there right now. 72 looks good in my eyes, Cliff. I don't know about you, but this minus stuff is getting a little old here. Anyway, we'll be back next week. By the way, we're working on a new format here. Some of you have been having a little trouble getting in and out of TalkShoe. They're trying to work on some of their issues, but we're going to try a little different format here over the next couple of weeks. We'll be sending out more information on that, and then we may have a practice show that we can have people join us on and kind of pressure test the new system here over the next couple of weeks. So keep your eyes out for that. We'll be back again next Friday, though, at noon, as always, for the next episode of IAQ Radio.
For IAQ Radio, I'm Spike Reel saying thanks for listening.